we embark on a journey into the grandest space exploration plan in human history. On June 12, 2026, a historic milestone quietly occurred as SpaceX officially went public. Hidden deep within the IPO listing documents lay an extraordinary clause. Elon Musk will be awarded 1 billion Class B shares if the company achieves a $7.5 trillion market capitalization and establishes a permanent Mars colony of at least 1 million residents. This staggering bonus could be worth between $600 billion and $1 trillion, proving this is no longer a whimsical daydream, but a strictly quantified mission. Stay with us, and by the end of tonight, we will dive deep into the ultimate technical realities to discover if a thriving city on Mars before 2050 is truly within our reach. Before we dive in, if you share our passion for drifting through the cosmos, please take a moment to like this video or subscribe. It's a small gesture, but it goes a long way in helping this channel connect with more inquisitive souls like yourself. Now, let the journey unfold. Tonight, our minds wander to the edge of a new frontier, standing on the silent, windswept coast of South Texas. There, silhouetted against the fading twilight, stands a monument to human ingenuity, a great silver ship designed to cross the black ocean of space. To understand how this titan intends to carry a new civilization to the red sands of Mars before the year 2050. We must first look at the incredible engineering that has already been solved. We must look at the sheer, raw power required to break free from the heavy embrace of Earth, and the magnificent technology that allows us to do it over and over again. At the very heart of this journey lies a machine born of fire and absolute precision, yet its underlying philosophy is one of total harmony and peace. This is the Raptor engine. It is an engineering masterpiece, a roaring furnace tamed by human hands to achieve the dream of interplanetary travel. Engineers had to solve a problem that had plagued rocketry for 3 generations: how to build an engine with absolute efficiency. They found their answer in a highly sophisticated thermodynamic process called the full-flow staged combustion cycle. It is a term that sounds heavy, like a textbook from an old university hall, but in truth, it is the ultimate expression of a concept that every man who has ever turned a wrench in his own garage understands implicitly. It is the quest for the perfect, flawless blend. Think back for a moment to the long, warm summer evenings of your youth. Imagine leaning over the engine bay of a classic Ford Mustang, the smell of oil and warm metal rising into the twilight air. Your fingers adjust the screws on a vintage Holley carburetor. You know that for that magnificent 8-cylinder engine to purr with absolute smoothness, the mixture of fuel and air must be exact. Every single drop of gasoline must be perfectly vaporized and blended with oxygen, so that when the spark ignites, there is no smoke, no waste, and no hesitation, just pure, clean, efficient power. For over half a century, traditional rocket engines could never achieve this perfect blend. In old designs, like the ones that carried the historic Apollo missions to the moon, engineers had to accept a wasteful compromise. They would burn a small portion of their fuel in a separate chamber just to spin the heavy pumps, and then they would dump that dirty exhaust overboard, leaving a dark streak of soot in the sky. The Raptor engine refuses to accept that waste. Through full-flow staged combustion, it turns all of its propellants into hot, high-pressure gases before they ever meet in the main combustion chamber. It is a gas-to-gas explosion, mixing with a thoroughness that no carburetor on Earth could ever match. The ignition is instantaneous, uniform, and complete, creating an immense, tightly controlled pressure that gives the ship the brute strength needed to lift thousands of tons off the ground. But building a powerful engine was only half the battle. To make a city on Mars truly possible, the ship had to be completely reusable. It could not be a relic of the past, discarded into the ocean after a single flight. And the secret to this reusability lies in a choice of material that feels beautifully old school. A nod to the heavy, durable craftsmanship of the past. Engineers bypassed the modern, fragile carbon fibers and chose instead a rugged alloy stainless steel 301. There is a quiet, comforting nostalgia in stainless steel. It is the material of classic diners, robust tools, and industrial machinery that refuses to quit. In the extreme environments of space, steel 301 possesses a brilliant dual nature. When exposed to the unimaginable, biting cold of liquid propellants, it does not become brittle. Instead, it grows tougher, stronger, and more resilient. And when the ship returns home, plunging through the upper atmosphere at thousands of miles per hour, the steel skin shrugs off the blistering, white-hot heat of re-entry. It requires no delicate, fragile ceramic tiles that take months to inspect and replace. It is tough, dependable, and honest metal, built to endure the hardships of the cosmic road and stand ready for the next journey with nothing more than a quick wipe down. The final piece of this magnificent solved puzzle stands tall against the Texas sky, a colossal launch tower that engineers affectionately call Mechazilla. In the old days of spaceflight, rockets required massive, heavy landing legs attached to their bases so they could touch down on concrete pads. But every pound of landing gear bolted to a rocket is a pound of cargo that cannot be taken to space. To solve this, engineers did something truly revolutionary. They removed the legs from the booster entirely and transferred the burden of landing to the ground. Imagine watching a giant 74-7 aircraft gently returning home, but instead of rolling down a runway, it is caught mid-air by a pair of giant mechanical arms extending from the hangar itself. As the massive super heavy booster descends from the heavens, guiding itself backward on a plume of fire, it slows to a hover next to the tower. Then, with the gentle, rhythmic click of metal meeting metal, the giant steel arms of Mechazilla reach out and catch the towering booster out of the sky. It is a breathtaking display of robotic precision, taming a giant of industrial weight as softly as a catcher receiving a baseball in his leather mitt. By catching the booster, the tower eliminates the need for landing gear, allowing the rocket to be placed right back onto the launch mount, refueled and prepared to fly again within hours. We lift our gaze higher, leaving the heavy pull of the ground beneath us, and find ourselves drifting silently in the great ink-black ocean of low Earth orbit. Down below, our home planet turns lazily, a brilliant blue and white marble wrapped in a thin, fragile blanket of clouds. Up here, there is no wind, no rustle of leaves, only the slow, majestic dance of stars. It is in this serene, weightless theater that we encounter the first great, unsolved mystery of our journey to the Red Planet, a cosmic wall that engineering has yet to fully conquer. To understand why the dream of establishing a city on Mars before the year 2050 remains suspended in the balance. We must look at what happens when the echoes of the launch have died away and the ship sits in the deep silence of space. When the great silver transport breaks free from the stubborn chains of Earth's gravity, it achieves a triumphant but costly victory to push its immense mass through the thickest, heaviest layers of our sky. Its engines have had to feast voraciously on their stores of propellant. By the time the spacecraft reaches the quiet sanctuary of orbit, its massive bellies are nearly dry. It sits in the darkness, a magnificent stallion, breathless after a frantic sprint, its tanks empty, to journey across the vast, lonely void to Mars. This ship needs a refill. It requires a process known to engineers as orbital refueling, a challenge that is simple to imagine but profoundly difficult to execute with the technology we possess today. For those of us who appreciate the steady precision of mid-century engineering, the idea of transferring fuel in motion carries a beautiful, familiar resonance. Think back to the quiet mornings of the 1950s and 60s, during the twilight of the golden age of aviation. Picture a massive Boeing B-52 stratotanker cruising smoothly above a sea of clouds, its wings catching the amber glow of a high-altitude sun. From its tail, a long, steady refueling boom extends downward into the thin air. Trailing just behind it, a heavy bomber approaches with infinite patience, closing the gap inch by inch until metal meets metal in a flawless, silent embrace. High above the weather, fuel flows smoothly from one bird to another, extending its reach across vast continents. It is a comforting, rhythmic display of human skill. But in the weightless void of orbit, transferring fuel is a completely different beast. It forces us into a brutal confrontation with the laws of thermal physics, a realm known as cryogenic fluid management. The fuels required to power our journey, liquid methane and liquid oxygen, are not ordinary liquids. They are volatile, restless spirits that must be kept at unimaginably cold temperatures to exist at all. Liquid oxygen must be chilled to nearly 300 degrees below zero, while liquid methane requires temperatures of more than 250 degrees below zero. They must be held in a state of deep, icy hibernation. The moment these ships enter the harsh glare of the unfiltered sun in space, a quiet, unrelenting battle begins. The thermal radiation of the sun strikes the silver hull, threatening to warm the tanks. If the temperature rises even a single fraction of a degree, the liquid propellants will begin to boil, turning into gas and venting uselessly into the void. Engineers call this phenomenon boil-off. To prevent this tragic loss, the ships must act like the finest, deepest stone cellars of Europe. Imagine a quiet, subterranean vault carved into the limestone hills of France, where a master winemaker stores his most precious vintages, no matter how fiercely the summer sun beats down on the fields above. The thick stone walls and deep insulation keep the air inside perfectly cool, dark, and still, preserving the delicate liquid for generations. Our silver ships use advanced, multi-layered reflective blankets of silver and gold foil separated by a vacuum to mimic these cool cellars. Yet, on orbit, time is our enemy. To launch an entire fleet of hundreds of transport ships, SpaceX must spend months launching thousands of tanker flights to fill them. While one ship waits for its companions to arrive, the sun beats down relentlessly. Over weeks and months, heat inevitably seeps through the insulation. The liquid boils, gas escapes, and the hard-earned fuel vanishes into the blackness. As of tonight, modern science has no closed loop. zero-loss solution to completely stop boil-off over long periods on a grand industrial scale. It is a technical puzzle whose pieces do not yet fit. Beneath the problem of heat lies an even stranger mystery: the unruliness of liquids in zero gravity. On Earth, gravity is a gentle, comforting hand that coaxes fluid to settle neatly at the bottom of a container. But in the weightless environment of orbit, fluid loses its manners. Liquid methane and oxygen do not sit still. Instead, they cling to the metallic walls, climb up the corners, or break apart into giant, floating orbs that drift lazily in the center of the vast aluminum caverns like silver ghosts. If you were to turn on a standard pump in this environment, it would suck in nothing but empty gas, destroying the intricate machinery through cavitation while leaving the floating spheres of fuel untouched. To solve this, engineers try to nudge the ship gently using tiny thrusters, creating a faint, artificial gravity to coax the liquids to settle against the valves. But doing this for thousands of tons of volatile fluid across a fleet of hundreds of docked ships without creating dangerous pressure drops or explosive bubbles is something human hands have never accomplished. We currently lack the space-rated, high-capacity pumping technology required to move oceans of supercold fuel in the dark. We leave the quiet orbit of Earth behind and drift deeper into the solar system, following the invisible pathways of gravity toward our destination. As we approach the red planet, the silver hull of our transport ship catches the faint, cold light of a distant sun. But as we prepare to arrive, we must confront the most terrifying engineering riddle of the entire journey. It is a cosmic trap that rocket scientists call the atmospheric paradox, and it leads directly into an unsolved aerodynamic nightmare known as supersonic retropropulsion. To understand why landing a great, heavy ship on Mars before the year 2050 remains an unconquered mountain, we must understand the peculiar, deceptive nature of the Martian sky. When we look at Mars from afar, it appears to have a beautiful, thin atmosphere, but to a landing spacecraft, that sky is a cruel illusion. The air on Mars is incredibly thin, possessing a density that is merely 1% of the thick, comforting atmosphere we enjoy on Earth. This creates a brutal paradox, a double-edged sword of physics. On one hand, because the air is so thin, there is not enough aerodynamic drag to slow down a massive 50-ton transport ship. If you were to deploy a traditional fabric parachute, even one as vast and wide as a football stadium, the thin Martian air would simply tear through it like tissue paper. Or the heavy ship would slam into the iron ground long before the parachute could ever blossom and slow it down. Yet, on the other hand, the atmosphere is just thick enough to be deadly. As the silver ship slams into the upper sky at 7.5 kilometers per second, a speed faster than a rifle bullet, the friction of that thin air still generates a blistering, white-hot wall of plasma. The air is too thin to save you by slowing you down, but it is thick enough to burn you to ash if your heat shield fails. It is like trying to walk through a heavy, choking fog that is too thin to hold your weight if you fall, but thick enough to blind you and scorch your face if you move too fast. For generations, every robot we have ever sent to Mars, from the small, brave rovers to the heavy landers, weighed less than 1 single ton. They were light enough to use a combination of heat shields, specialized parachutes, and small, delicate retro-rockets to touch down safely. But a ship built to carry a human settlement is a colossus. It is a towering silver skyscraper of steel and cargo, and for a ship of this scale, the old ways of landing are completely useless. This brings us to the edge of modern engineering, where science currently possesses no proven solution. To survive the landing, the ship must perform a maneuver that feels almost unnatural. After using its belly-mounted heat shield to scrub off the initial terrifying speeds of entry, the ship must use its automated guidance flaps to lurch through the sky, flipping itself upright in the middle of the supersonic airflow. Once upright, it must ignite its powerful Raptor engines directly into the oncoming wind that is rushing up from the planet below. This is supersonic retropropulsion, the act of using rocket fire as a supersonic brake. For those of us who love the timeless lore of the sea, this maneuver carries the heart-pounding tension of an old maritime tale. Imagine a seasoned sea captain commanding a massive wooden clipper ship during a violent storm in the roaring 20s of the North Atlantic. The vessel is rushing toward a jagged, rocky coastline at a terrifying speed, driven by relentless, screaming winds. In a desperate bid to save his crew, the captain orders the crew to throw the heavy sails into reverse, forcing the canvas to fight directly against the fury of the gale. The wooden hull groans under the immense, unnatural pressure as the colliding forces of wind and wood clash, threatening to snap the masts and rip the ship apart before it can come to a halt. In the thin air of Mars, the clashing forces are even more chaotic. When the ship ignites its engines forward into the oncoming supersonic wind, it creates a brutal phenomenon known as an aerodynamic interaction. The high-velocity streams of fire erupting from the rocket engines smash directly into the supersonic atmospheric gas flowing upward. This collision creates a violent, unpredictable dance of fluid dynamics. Instead of a smooth, steady deceleration, the meeting of these two supersonic forces creates massive, unstable shock waves that whip around the silver hull of the ship like invisible tornadoes. These chaotic shock waves shake the vessel with a ferocity that can cause extreme structural vibrations. They distort the airflow around the steering fins, rendering them almost useless. The rocket fire can actually wrap around the sides of the vehicle, threatening to melt the very flaps meant to keep it stable. This is the nightmare that supercomputers on Earth are still struggling to solve tonight. The physics of these colliding supersonic gases are so incredibly complex, so inherently turbulent, that our finest mathematical models cannot perfectly predict how the ship will behave from 1 millisecond to the next. We currently have zero real-world data at this massive industrial scale. We have never tested a 50-ton vehicle performing this fiery dance in a real atmosphere. If the automated flight computer takes even a fraction of a second, a mere 0.1 seconds too long, to adjust the angle of the engine thrust to counter a sudden, violent shockwave, the great silver ship will lose its balance. It will roll over, break apart, and be scattered across the desert sands. As we stand tonight, in the year 26, this remains an open wound in the blueprint of Mars colonization, a hurdle of pure, raw physics that human ingenuity has yet to tame. To understand why the dream of establishing a civilization on the Red Planet before the year 2050 is facing an invisible wall, we must look at the cold, unbending geometry of space. Earth and Mars are like two runners on a grand celestial racetrack, but they do not run at the same speed. Earth, sitting closer to the warm light of the sun, completes its lap in 12 months. Mars, traveling along a wider, more distant path, takes nearly 2 Earth years to loop around. Because of this cosmic difference in speed, the two planets are usually separated by a vast, impassable ocean of empty space. But once in a while, their orbits align. This alignment occurs precisely every 26 months. Rocket scientists call this rare moment a launch window, the only time when the bridge between the worlds is short enough for our silver transport ships to make the crossing. For those of us who find comfort in the quiet heritage of the American railroads, this celestial cycle feels deeply familiar. Think back to the golden age of steam, to a quiet, brick-walled station platform on a crisp autumn morning. You pull a heavy, gold-plated Elgin pocket watch from your vest pocket, watching the steady, rhythmic swing of the mechanical pendulum. On the wooden bench beside you sits the great leather-bound timetable. You know with absolute certainty that the heavy iron locomotive will not arrive early, nor can it delay. It must wait for the exact moment when the tracks ahead are clear, when the switches are flipped and the schedule aligns. If you miss that single, precious train, the iron gates swing shut, and you must wait a very long time in the quiet station for the next engine to roll through the mist. In the cosmic theater, this timetable is absolute. And when we look at the calendar from this present year of 26 to the target year of 2050, we discover a chilling mathematical reality. There are exactly 11 launch windows available to us. 11 opportunities, 11 ticks of the great celestial clock. If human ingenuity cannot find a way to move an entire civilization's worth of cargo and people within those 11 brief windows, the deadline of 2050 slips away into the dark. This is where the grand blueprint of colonization collides with an unsolved industrial nightmare on the ground. To understand the scale of this problem, remember that each individual Mars-bound transport ship cannot travel alone, as we explored before. Each silver ship arrives in orbit empty and requires 4 to 8 tanker flights just to fill its belly with super-cold fuel. If SpaceX wishes to launch a fleet of just 100 transport ships during a single launch window, they must execute between 500 and 800 successful launches within a very tight time frame of just a few weeks. This creates an unimaginable bottleneck for industrial logistics. Imagine the great Chicago rail yards during the peak of the mid-century industrial boom, multiplied by 10. Picture thousands of heavy freight cars, loaded with coal, iron, and steel, all converging on a single junction point at the exact same hour. The tracks groan under the weight, the switches overheat, and the air is thick with the frantic energy of an overtaxed system. On Earth today, we simply do not possess the industrial infrastructure to handle such a relentless cadence. To launch multiple giant rockets every single day would require oceans of liquid oxygen and methane fuel volumes so vast that they would require dedicated pipelines and chemical factories working around the clock just to supply a single launch site. The immense frost clouds of venting gas would blanket counties. Furthermore, the sheer acoustic violence of hundreds of launches within a month would create an environmental and regulatory crisis, rattling windows and disrupting air traffic control across entire hemispheres. As of tonight, modern industrial engineering has no blueprint for a spaceport that can operate with the frequency of a busy commercial airport. And yet, the logistics nightmare does not end on Earth. It follows the Hamdoi across the black void to the destination. If hundreds of silver ships successfully depart Earth during the brief alignment, They will travel across the cosmic ocean together, moving like a silent, ghostly caravan through the dark. Because they all left at the same time. They will all arrive at Mars at the exact same time. Picture hundreds of skyscraper-sized vessels all converging on the thin, fragile atmosphere of Mars within a single month. There are no grand air traffic control towers on Mars, no paved runways, and no radar networks to guide them home. Each ship must perform its terrifying supersonic retro-propulsion landing maneuver in rapid succession. As each Colossus touches down, its monstrous engines will blast thousands of tons of red iron dust into the thin air, creating an artificial global dust storm that will blind the senses of every ship following just minutes behind it. A single error in timing, a single collision in the dust-choked sky could cause a catastrophic chain reaction. We currently have no automated network, no orbital traffic system, and no landing pad infrastructure capable of managing a swarm of giant spaceships arriving simultaneously on a dead world. We have traversed the Black Ocean and touched the iron soil of Mars, but as the engines cool in the freezing night, a stark reality settles over the dunes. Survival here is no longer a question of speed, but of absolute endurance. We must now build a world from scratch, where every breath is engineered and every drop of water is sacred. Mars is a world of bone-chilling desolation, where the night temperatures regularly plunge to over 100 degrees below zero. To survive in this eternal winter, a human settlement requires a constant, unyielding heartbeat, a reliable stream of baseline electricity to keep the heaters running and the oxygen flowing. For many years, the most optimistic dreamers looked to the sky and believed the sun would solve all our problems. They pinned their hopes on the technology of photovoltaics, the elegant science of using ultra-thin silicon wafers to capture traveling photons and convert them directly into electrical currents. It sounds clean, simple, and infinitely peaceful. But when we look at the raw physics of our solar system, we discover that relying on photovoltaics on Mars is a tragic miscalculation, because the red planet sits so much farther from the warmth of the sun than our home world. The solar irradiance, the actual strength of the sun's rays hitting the ground, is less than half of what we enjoy on Earth. To depend on solar panels on Mars is like trying to illuminate a grand historic manor house during a freezing winter afternoon, using only the faint, watery light that filters through the intricate stained glass windows of an ancient stone cathedral. The light is beautiful to look at, casting soft, colorful patterns across the floor, but it is thin, fragile, and utterly lacks the heat and substance required to keep the heavy frost from creeping inside the rooms. And beneath this permanent weakness of sunlight lies an even greater threat: the terrifying Martian weather. Mars is home to global dust storms, cataclysms of fine, rust-colored powder that rise from the desert floors and swallow the entire planet for months at a time. When these storms rage, they turn the daytime sky into a dark, choking amber twilight, blocking out up to 99% of all available sunlight. We watched this happen to our finest machines in the past. The brave little Opportunity rover was caught in one of these global storms. Its solar panels were slowly covered in a fine layer of silt. Its batteries drained into the freezing dark, and it was silenced forever. For a city filled with thousands of people, relying on photovoltaics means gambling your life on the unpredictable whims of a hostile sky. If a storm strikes, the lights go out, the air systems freeze, and the colony dies in the dark. This inevitable failure of light forced rocket engineers to turn away from the sun and look toward the most reliable source of heat known to human science: nuclear fission. This is the technology found in a brilliant, compact reactor known as kilopower, developed under a research program called CRUST-Y. At the very heart of this machine sits a solid, heavy core of uranium-235. It does not look like a grand power plant. It is small, rugged, and completely self-contained, using controlled atomic decay to generate a fierce, unyielding heat. For those of us who appreciate the solid, dependable craftsmanship of the past, there is a profound, comforting beauty to this nuclear design. It operates on the exact same principle as an old, heavy cast-iron wood stove sitting in the corner of a cozy cabin in the mountains of Vermont during a ferocious winter blizzard. Outside, the sub-zero winds may howl, and the snow may drift high against the doors, burying the roads and freezing the rivers. But inside the cabin, that solid iron stove glows with a steady, deep red heat, radiating warmth hour after hour, completely indifferent to the chaos of the weather outside. The kilopower reactor works exactly like that trusted stove. It uses advanced Stirling engines, simple mechanical pistons driven by the expansion of heated gas to turn that atomic warmth into steady electricity. It works 24 hours a day, 7 days a week, completely blind to whether the sun is shining or hidden behind a continent of red dust. Yet, as we look closer at the timeline of 2050, we hit a massive, unsolved engineering wall. The kilopower reactors we have successfully built and tested are tiny. They are designed to produce only 10 kilowatts of power, barely enough to run a few kitchen appliances in a suburban home. A true, self-sustaining industrial city on Mars requires millions of watts, a scale known to science as megawatt capacity, to operate heavy automated mining drills, to melt giant sheets of frozen underground glaciers, and to keep the atmosphere inside massive housing complexes breathable. We need an atomic furnace of monstrous proportions. This is where the technology breaks down, because scaling a nuclear reactor up to a megawatt capacity introduces problems we currently have no way to solve. High-power fission reactors require immense, heavy shielding tons of lead, concrete, and complex liquid cooling loops to prevent lethal gamma radiation from poisoning the human colony. A megawatt reactor is a colossus of extreme weight, making it nearly impossible to launch safely off the Earth using our current rocket fleets. Furthermore, launching high-mass radioactive payloads introduces a terrifying regulatory and environmental nightmare. If a commercial rocket carrying a massive industrial nuclear core were to explode on the launch pad, it could contaminate entire coastlines for generations. Finally, shedding the immense waste heat generated by a giant nuclear plant in the thin, insulating air of Mars is a thermodynamic riddle that has left our finest scientists baffled. As of tonight, we have no safe, scalable blueprint for an atomic grid on a dead world. We find ourselves resting on the rusted soil of Mars, inside the safe, insulated sanctuary of our imagination. Outside our windows, the thin, dry winds of the red planet whisper across empty, ancient dunes, a stark reminder that this distant world possesses no native air for us to breathe. Its sky is a cold, choking blanket made almost entirely of toxic carbon dioxide. To build a permanent home here before the year 2050, human beings must solve the most fundamental riddle of survival: how to manufacture the very air that sustains life, transforming a dead wasteland into a cradle of breath. Deep within the modern blueprints of exploration sits a triumphant piece of technology that scientists call solid oxide electrolysis. This is not a mere theory drawn on a chalkboard. It is an elegant process that was successfully tested on the Martian surface by a small, brave instrument named MOXIE. The phrase solid oxide electrolysis sounds highly technical, belonging to the clean, sterile laboratories of advanced aerospace institutes, but its core chemical truth is beautiful, simple, and deeply anchored in the classic mechanics of the past. It is simply the art of using extreme heat and steady electrical current to strip away the useless parts of a heavy molecule, leaving behind pure, life-giving oxygen. For those of us who appreciate the heavy, honest craftsmanship of bygone days, this sophisticated process can be perfectly understood if you close your eyes and imagine an old blacksmith's forge from the 19th century. Picture the dim, amber light of a brick workshop on a crisp autumn evening, the smell of coal smoke and warm iron thick in the air. The blacksmith takes a rough, heavily rusted piece of iron ore raw, stubborn, and full of earthy impurities, and buries it deep within the glowing, white-hot coals of his hearth. As the bellows pump air, the intense heat softens the ancient bonds of the stone. Then, with a heavy, rhythmic strike of his hammer against the anvil, the smith cleanly drives out the brittle, useless impurities, separating the dross from the pure, strong, and useful iron underneath. The solid oxide electrolysis cell works exactly like that vintage forge. It takes the carbon dioxide molecules from the thin Martian sky, heats them to a blistering 800 degrees Celsius, and applies a steady current across a specialized ceramic membrane made of zirconia. The extreme heat softens the molecular bonds, and the electricity acts precisely like the blacksmith's hammer, cleanly snapping the oxygen atoms away from the heavy carbon core. The machine collects the pure, breathable gas on one side, while venting the harmless carbon monoxide back into the night. It is a mechanical miracle that has already proven it can harvest the sky of a foreign world. Yet, when we shift our gaze from this isolated success toward the grand dream of sustaining a large, permanent civilization, we run headfirst into a towering engineering crisis that modern science has no way to solve. This is the daunting, unsolved riddle of industrial scaling. The brave little MOXIE instrument was a prototype, a mechanical proof of concept, roughly the size of a standard car battery. It produced a modest 12 grams of oxygen per hour, barely enough to keep a small puppy or a single mouse alive in a plastic cage. To sustain a true living community of pioneers before 2050, we cannot rely on a battery-sized device. We need a colossal, multi-story chemical processing plant that operates 24 hours a day, 7 days a week, multiplying that microscopic production by hundreds of thousands of times. When you attempt to scale solid oxide electrolysis up to an industrial dimension, the elegant physics of the laboratory encounter the harsh, gritty realities of the Martian environment. The first great unsolved technical barrier is the fine, abrasive dust of the red planet. Martian dust is not like the soft, organic soil of our gardens. It is an incredibly fine, electrostatically charged powder made of sharp, shattered iron oxide crystals, finer than talcum powder and as sharp as crushed glass. To feed a giant oxygen factory, massive mechanical compressors must suck in millions of cubic feet of the thin Martian atmosphere every single hour. As this air is drawn in, it carries the microscopic dust with it. These sharp, jagged particles clog the submicron pores of the delicate zirconia ceramic membranes, scratching the microscopic pathways and causing the system to short-circuit or crack under the immense 800-degree heat. Currently, material science has no filtration technology capable of handling this relentless, abrasive silt on an industrial scale, without the filters becoming choked and useless within a matter of weeks. See. Furthermore, maintaining a giant, multi-ton ceramic core at a uniform, blistering temperature of 800 degrees Celsius creates a massive thermodynamic nightmare. If one section of the large industrial stack cools down by even a few degrees due to the freezing Martian winds, the intense thermal stress will cause the brittle ceramic to fracture instantly, causing a catastrophic structural failure. On Earth, a chemical plant of this immense complexity requires a team of hundreds of highly trained engineers, pipe fitters, and technicians working in rotating shifts to clean valves, replace cracked seals, and monitor pressures. On Mars, before the year 2050, this entire monumental industrial matrix must run completely automatically, managed by artificial intelligence, long before the first large waves of human settlers ever arrive. We currently possess no autonomous robotic systems capable of performing intricate mechanical maintenance on high temperature, high-pressure chemical plumbing in the middle of a dead, dust-choked desert. We find ourselves walking along the quiet, rust-colored plains of Mars within the peaceful sanctuary of our imagination. As we look down at the dry, dusty soil beneath our boots, we must confront the great, fundamental paradox of water and earth on this foreign world. To build a permanent home here before the year 2050, humanity must secure a boundless supply of water and reclaim the toxic ground. Human eyes have mapped the hidden riches of the Red Desert with absolute precision. High above the dust-choked sky, a magnificent robotic sentinel called the Mars Reconnaissance Orbiter has spent decades silently circling the planet in the quiet void. Utilizing an advanced ground-penetrating radar system, this spacecraft has peeled back the rusty topsoil to reveal a breathtaking truth. Vast, pristine sheets of pure water ice are slumbering just a few feet beneath the surface, stretching for thousands of miles across a wide, smooth northern plain known to astronomers as Arcadia Planitia. This magnificent discovery feels deeply identical to walking across the rolling hills of an old family farm that has been passed down through generations. Imagine standing on a dry, sun-baked pasture in the middle of a late July drought, your boots kicking up clouds of powdery earth. For years, the surface seemed barren and parched, but then an old, wise water dowser walks the fence line, his trusted hazel rod dipping sharply toward the grass. He looks at you with a knowing smile and tells you that just a few feet beneath your soles runs a cold, sweet, and boundless underground spring, waiting silently in the deep dark to turn your dry fields into a lush, green paradise. Thanks to satellite radar, we have found that hidden spring on Mars. The maps are finished, the coordinates are locked, and the ice is waiting. Furthermore, inside the quiet chambers of the International Space Station, our scientists have already mastered the art of advanced plant habitats, proving that crops can grow beautifully in indoor, soil-free hydroponic systems under the gentle glow of light-emitting diodes. The blueprint for nourishment is ready. But knowing where the water sleeps is a solved victory that brings us directly to a fierce, unsolved nightmare of mechanical engineering the daunting challenge of autonomous extraction in an extreme environment. The ice of Mars is not like the soft, melting snow of an April thaw in New England, because it has been frozen at temperatures of nearly 100 degrees below zero for millions of years. This subterranean ice has changed its physical nature entirely. It has become as dense, stubborn, and unforgiving as solid granite rock. To harvest these frozen underground lakes, we cannot send crews of rugged roughnecks or seasoned oil well drillers. The intense cosmic radiation and the biting cold make it impossible for human beings to stand on the surface for hours at a time to operate heavy machinery. The entire operation must be executed by completely autonomous robotic drilling platforms, working silently in the desert long before the first large waves of human pioneers ever arrive. But drilling into granite-hard ice requires immense, continuous mechanical torque. In the freezing wilderness, the heavy steel drill bits rapidly overheat, dull, and snap under the unnatural strain. In the deep, lonely silence of Mars, there is no mechanic to walk out to the rig with a toolbox. No spare parts arriving on a flatbed truck, and no human hand to clear a jammed drill string miles away from help. As of tonight, modern robotics has zero proven solutions for high capacity. Heavy industrial mining that can run entirely by itself without breaking down in the sub-zero dark. This mechanical struggle brings to mind the quiet, slow patience of an old master gardener preparing his tools for the winter. Imagine sitting in a warm, cedar-scented shed on a quiet December afternoon, watching the snow drift lazily against the glass panels. You hold an old, trusted iron spade that has gathered a thick coat of stubborn, orange rust over the long autumn. You do not rush the work. You take a piece of steel wool and oil, and you slowly, methodically scrub the metal, restoring its clean, sharp edge so it can slice through the earth when the thaws finally return. It requires a human touch, a sense of care, and a patient eye. On Mars, our machines possess no human touch to guide them when the iron freezes and the steel gears grind to a halt. And beneath the cold hardness of the ice lies an even darker chemical villain, hidden inside the very soil itself, perchlorate salts. The topsoil of Mars is heavily contaminated with these toxic chemical compounds, which make up roughly 1% of the entire desert floor. To the human body, perchlorates are a silent, devastating poison, completely disrupting the thyroid gland and destroying our ability to regulate metabolism, warmth, and life itself. While our scientists on Earth have successfully found specific strains of specialized bacteria that can eat and destroy perchlorates inside tiny, pristine glass test tubes in a laboratory, we are completely helpless when it comes to scaling this process up to an industrial dimension. To build housing complexes, massive greenhouses, and green spaces for thousands of people, we would need to detoxify millions of tons of raw Martian Earth. We currently possess no engineering blueprint to wash an entire planet's soil, no industrial-scale bioreactors capable of processing mountains of toxic dirt, and no way to keep these delicate, microscopic bacteria alive in the freezing, irradiated desert air. The ground beneath our feet remains a beautiful but deadly trap. Deep within the architecture of modern space travel sits a monument to human ingenuity known as the Environmental Control and Life Support System, or simply ECLSS. This is not a mere dream drawn on a chalkboard. It is a mature, brilliant technology that has reached breathtaking heights inside the quiet cabins of the International Space Station for over 2 decades, floating in the silent void of low Earth orbit. This closed-loop system has proven that human beings can manufacture a miniature, self-contained ecosystem. Today, our finest systems can masterfully recapture and recycle 98% of all the water and air within a spacecraft. It takes the carbon dioxide exhaled by the crew, filters it through advanced chemical beds, and breathes fresh, crisp oxygen back into the rooms. It gathers the moisture from human breath, the humidity in the air, and even the wastewater of the station, passing it through microscopic purification layers and high-temperature catalytic reactors. It transforms what was once waste into water that is cleaner, purer, and sweeter than the finest mountain springs of the Rocky Mountains. It is an extraordinary testament to human engineering, a mechanical replication of Mother Nature herself, working flawlessly in the dark. But when we transport this beautiful loop across the black ocean of space to the red sands of Mars, our blueprint encounters a silent, deadly obstacle, the unyielding reality of mechanical friction. This brings us directly to the edge of an unsolved engineering crisis that modern science has no way to break. Rocket scientists call it the valve paradox of self-repair. You see, the magnificent life support loop on the space station is not truly independent. It is quietly tied to a continuous, dependable lifeline from Earth. Every few months, automated cargo ships launch from Florida or Kazakhstan, carrying fresh filtration beds, new electronic control boards, and specialized mechanical components to replace parts that have inevitably grown old and worn on Mars before the year 2050. That lifeline is stretched across a 2-year celestial abyss, leaving the colony completely on its own. For those of us who appreciate the steady, reliable heritage of fine machinery, this paradox can be perfectly understood if you imagine an ancient, beautiful Swiss grandfather clock that has been passed down through generations of your family. Picture the tall, rich mahogany case standing in the quiet corner of a study on a crisp autumn evening. Inside, a complex web of brass gears, tiny escapements, and a heavy copper pendulum tick with comforting, rhythmic precision. It is a closed system of perfect timekeeping. But imagine if one single microscopic tooth on a tiny gear becomes worn down by the friction of a century, or if a single rubber seal keeping the internal oils from drying out cracks in the winter cold. Suddenly, the weights stop dropping. The pendulum freezes, and the magnificent timepiece falls completely silent. To fix it, you cannot simply wish it to run. You need a master horologist with specialized tools and an exact replacement part made of highly specific materials. On Mars, the city's life support grid is filled with hundreds of thousands of these tiny teeth, delicate springs, and rubber seals. To keep the air moving, the system relies on high-speed mechanical compressors to regulate the pressure between rooms. It utilizes intricate solenoid valves to monitor the purity of the water. It requires delicate electronic sensors. The romantic vision of space colonization suggests that if a part breaks, the settlers can simply use advanced 3-dimensional printers to manufacture a new one out of local Martian dust. But this is a grand illusion. While a modern 3-dimensional printer can easily forge a rough metal bracket or a simple plastic housing, it cannot manufacture a high-precision computer microchip from raw sand, nor can it forge a complex, flexible rubber elastomer that must maintain its elasticity at 200 degrees below zero while sealing a valve down to a millionth of an inch. As of tonight, modern materials science has zero solutions for a manufacturing system that can replicate its own high-fidelity micromechanics away from the massive industrial supply chains of Earth. If a single rubber valve inside the main water processor tears and there is no exact replacement in the storehouse, the entire 98% recycling loop collapses. The water turns stagnant, the oxygen systems choke on their own impurities, and the clock of human survival begins to wind down. The circle is broken by a single piece of worn rubber. As the hum of the recycling valves fades into the quiet night, we realize that even if we forge the perfect machine, an even greater vulnerability slumbers within its steel walls. We can patch a leaky pipe or reboot a frozen computer, but we cannot easily re-engineer the fragile architecture of the human form, for in this cosmic theater, our own flesh and bone remains the most delicate link of all. When we think of the dangers of space, our minds naturally turn to our own star, the Sun. The Sun is a magnificent roaring furnace of thermonuclear energy, but it is prone to violent, unpredictable tantrums. Every so often, it erupts in a massive event, known as a solar particle event, blasting a torrential storm of high-energy protons across the solar system like a cosmic hurricane. It sounds terrifying, a wave of invisible fire rushing through the dark. But for those of us who remember the classic summer afternoons of our youth spent listening to the distant rumble of thunder across the plains of the Midwest, this solar weather carries a beautiful, familiar rhythm. Imagine sitting on the porch of an old timber farmhouse on a sultry July evening. In the distance, the shortwave radio on the table begins to crackle with static, and you see the sky turning a deep, bruised purple on the horizon. You do not panic. You simply walk inside, close the heavy oak shutters, pull down the storm windows, and sit safely by the warmth of the fireplace while the rain lashes against the glass. In the theater of space, rocket engineers have built the exact equivalent of that sturdy farmhouse. Because solar protons are relatively light and carry a modest amount of energy, we can block them with absolute certainty. High-tech satellites sitting between Earth and the Sun act as our early warning system, giving our pioneers hours of notice before a solar storm arrives. When the alarm sounds, the settlers simply walk into reinforced underground shelters covered by a layer of Martian earth known to science as regolith, that is just a few meters thick. Or they hide behind thick, protective walls filled with the colony's water reserves, using the rich hydrogen molecules of ordinary water to absorb the impact of the solar storm completely. The sun's fury has been tamed, the shields work, the blueprints are proven, and the pioneers can sleep safely beneath the soil. But as the storm of the sun passes and the night grows still, we must confront an infinitely more sinister, unsolved villain lurking in the deep dark, the galactic cosmic rays. These rays do not belong to our solar system. They are ancient, restless ghosts born millions of years ago in the violent, cataclysmic deaths of giant stars across the farthest reaches of the Milky Way galaxy. They are not light protons. They are heavy, highly stripped atomic nuclei, like iron ions, moving through the void at nearly the speed of light. To understand the unique, haunting nature of galactic cosmic rays, imagine sitting in a quiet, wood-paneled study late at night, playing a favorite old jazz record on a vintage vinyl turntable. Between the tracks, in the deep silence of the room, you hear that faint, persistent hiss and crackle of the needle riding the grooves of the plastic. It is not a sudden storm. It is a permanent background noise that fills the space, ubiquitous, relentless, and completely indifferent to the walls of the house. Galactic cosmic rays are that ghostly crackle of the universe. They rain down upon Mars from every direction, every second of every day, completely unceasing. And this is where modern science hits an absolute wall of physics, because these heavy cosmic bullets defy all ordinary forms of shielding. If you try to block a galactic cosmic ray using a thick sheet of heavy metal, like lead or aluminum, you trigger a terrifying phenomenon known as secondary radiation. The iron nucleus, traveling at near light speed, strikes the atoms of the metal shield with such immense energy that it shatters them completely, creating a microscopic explosion. Instead of stopping the danger, the metal shield acts like a pane of glass struck by a stone, exploding into a shower of thousands of fast-moving subatomic fragments and shrapnel that tear through the interior of the ship. The shield actually makes the radiation environment deadlier than the open void. To the human body, this relentless cosmic hiss is devastating. As these heavy particles slide through the walls of the bunkers and pass through human flesh, they act like microscopic razor blades, cleanly cutting through both strands of the double helix DNA ladder within our cells. Over a few years of living on Mars, this continuous genetic damage causes extreme rates of cancer mutation, even more chillingly. As the heavy ions strike the delicate tissues of the brain, they destroy the complex tracks of neuron pathways, causing an insidious form of cognitive decline that space medicine calls space Alzheimer's. The pioneers would slowly lose their memories, their sharp problem-solving skills, and their clarity of thought, their minds fading away into the red dust. To stop them, engineers have dreamed of creating active magnetic shielding, deploying massive, superconducting magnets around the colony to create an artificial magnetic bubble, mimicking the great protective field of Mother Earth. But the physics are unyielding. To bend a particle moving at the speed of light requires a magnet of unimaginable weight and an electrical grid larger than a modern city. As of tonight, material science has zero solutions for a power source or a magnet light enough to be taken to space that can turn away these galactic travelers. Before the year 2050, human beings remain completely vulnerable to this quiet, eroding rain of deep space. For over 2 decades, inside the quiet, metallic cabins of the International Space Station, our scientists have studied how the human body reacts to the weightless void. When we first sent brave souls into orbit for months at a time, we watched with great concern as their muscles began to wither and their bones leached calcium into their blood, losing their strength like an old wooden porch, losing its structural integrity to the damp spring rains. But human ingenuity did not back down. Our engineers designed and built the Advanced Resistive Exercise Device, a magnificent piece of heavy industrial machinery that feels beautifully familiar, like a robust cast iron weight machine from an old-school hometown gymnasium. Imagine the reassuring weight of that classic iron. By strapping themselves into this specialized machine for 2 hours every single day, pulling and pushing against powerful vacuum cylinders that simulate the heavy, comforting resistance of Earth, our astronauts can trick their muscles and skeletons into staying strong. Combined with advanced space sports medicine, highly targeted pharmaceutical compounds that slow down bone erosion, and specialized high-protein diets, we have successfully mastered the short-term journey. Today, we can confidently fly a man through the weightless dark for 1 or 2 years and bring him back safely to his family, his boots stepping firmly and securely onto the green grass of home. The short-term mechanics of human survival are a solved victory, a proven blueprint that gives us great hope. But as we leave the familiar orbit of Earth and look toward the red horizon of Mars, our medical blueprint encounters a permanent, deceptive middle ground that science has no way to fix: the unyielding reality of 0.38 g. You see, Mars is not weightless. It possesses a permanent gravity that is merely 38% of what we feel on Earth. It is a quiet, ghostly force that never sleeps, and it represents a biological environment for which the human body has zero evolutionary programming. For millions of years, every valve in our hearts, every cell in our bones, and every vessel in our brains evolved to fight against the heavy, steady pull of one full Earth gravity. The moment a pioneer steps onto Mars, that ancient balance is shattered. The most immediate and terrifying expression of this low-gravity environment is a silent, fluid migration within the human flesh. On Earth, our heavy gravity acts like a gentle, continuous hand that pulls our blood, water, and bodily fluids downward, keeping them properly distributed toward our legs and lower torso. But at 0.38 g, that pulling hand is too weak. The fluids lose their anchor and begin to migrate upward, flooding into the chest, the neck, and the skull, filling the head with an unnatural, continuous internal pressure that never goes away. To understand this silent, mounting pressure, close your eyes and imagine sitting in the basement of a grand, historic Victorian house on a bitterly cold January night. Deep in the dark, the old cast iron, coal-fired boiler hums with a low, steady vibration, pushing hot water through an intricate web of copper heating pipes that run up through the wooden floors to warm the bedrooms high above. If a valve becomes partially blocked, or if the system is forced to run continuously without relief, the fluid pressure inside those hidden copper lines begins to rise slowly, silently, expanding against the metal joints and pushing against the plaster walls. You cannot see the water moving from the outside, and you cannot hear its slow, heavy push, but the pressure is there, mounting inside the very structure of the house, day after day, winter after winter. Inside the human skull on Mars, this rising fluid pressure presses relentlessly against the back of the eyes. Rocket doctors call this creeping medical crisis spaceflight-associated neuroocular syndrome, or simply SANS. The continuous, unyielding pressure physically flattens the back of the delicate eyeball, squeezing the blood vessels and causing the optic nerve to swell in the absolute dark of the skull. Slowly, over the course of months and years, the pioneer's vision begins to fail. The sharp, clean lines of the Martian landscape begin to blur, replaced by dark spots and distorted shadows, leading eventually to permanent, irreversible blindness. As of tonight, modern medicine has zero solutions to stop this fluid migration. Zero ways to lower the pressure inside the skull without dangerous continuous medical intervention, and no way to protect the human eye from this slow, physical deformation over a lifetime. We cannot perform surgery on the gravity of a planet. And we cannot change the plumbing of the human soul. And beneath the eyes lies the deep, slow tragedy of the skeleton. Every single month spent living at 38% gravity. The human body looks at its heavy, calcium-rich bones and decides they are a luxury it no longer needs to maintain. The body systematically dissolves its own framework, flushing the calcium out through the kidneys. Modern science does not know if this osteoporosis will ever hit a safe plateau, or if after a decade of living in the red desert, a pioneer's bones will become as brittle and fragile as old, spun glass. If their skeletons turn to glass, they can never return to the heavy 1G embrace of Earth. Their legs would snap under their own weight, and their hearts would fail instantly. They would be exiled forever by their own biology, prisoners of a low-gravity world. To build a true, permanent civilization on the red sands of Mars before the year 2050. Humanity cannot merely exist as a team of aging scientists. We must become a multi-generational society. We must be able to birth a new generation under a foreign sky. When we look at the challenge of preserving the spark of life across the vast, irradiated ocean of space, modern science has achieved a remarkable victory. This is the technology of cellular cryopreservation, the highly precise art of freezing reproductive cells, such as sperm and eggs, at ultra-low temperatures so that their biological clocks are stopped completely, locked in a state of perfect, timeless hibernation. For those of us who appreciate the quiet, rustic traditions of the past, this high-tech biological bank can be perfectly understood if you close your eyes and imagine a deep, stone-walled root cellar beneath an old New England barn during the heart of a bitter January winter. Outside, the sub-zero winds howl across the frozen fields, and the snow drifts high against the heavy oak doors. But down in the dark, silent cellar, insulated by feet of earth and thick fieldstone, sits a collection of wooden crates filled with heirloom seeds gathered from the autumn harvest. Those seeds do not grow in the dark, nor do they spoil. They sleep in a calm, frost-protected stasis, preserving the perfect genetic blueprint of summer corn. Sweet pumpkins and crisp apples, completely untouched by the freezing fury of the winter above. When the spring thaws finally return months later, those sleeping seeds can be brought into the warmth, planted in the soil, and they will blossom with absolute vitality. Our planetary scientists have designed the exact equivalent of that quiet root cellar on Mars by burying deep cryopreservation banks dozens of meters beneath the heavy Martian soil, inside ancient, hollow lava tubes. We can protect these delicate human cells from the harsh rain of space radiation. The technology to freeze, store, and safely thaw these foundational elements of life is already a proven reality, a solved victory, waiting in our modern medical armory. But thawing a cell in a laboratory is a brief success that brings us directly to a fierce, unsolved wall of evolutionary biology, the sheer physical impossibility of carrying a mammalian pregnancy to term in a low-gravity environment. This is where our grand blueprint for a city of 1 million people before 2050 hits a terrifying silence. You see, the development of a human embryo inside the womb is a magnificent, intricate construction project that relies on constant mechanical signals from the environment for hundreds of millions of years. Every single stage of mammalian reproduction evolved under the steady, unyielding downward pull of one full Earth gravity. The moment an egg is fertilized, the tiny cluster of cells must know how to divide, how to migrate, and how to shape themselves into the complex architecture of a human body. The cells use the constant weight of one full Earth gravity as their primary compass, a biological plumb line that tells them which way is up, which way is down, and where to place the heart, the spine, and the brain. But on Mars, that compass is broken at a permanent level of 0.38 g, less than 40% of Earth's gravity. The physical signals are too faint, too distorted. Without the heavy, comforting pull of Earth, the delicate embryonic cells lose their way, failing to attach properly to the uterine wall or dividing into chaotic, irregular patterns. Furthermore, the relentless background rain of galactic cosmic rays continuously slices through the mother's torso, damaging the fragile chromosomes of the developing fetus at the exact moment they are trying to replicate. The result is a tragic, near-absolute rate of early miscarriage or severe developmental deformities. As of tonight, Ihokvu True has zero solutions for this problem. We have never successfully bred a single mammal in a partial gravity environment, and we cannot build a factory to manufacture a mother's gravity. Without a natural way to reproduce, the colony remains a dead-end street. And beneath the mystery of birth lies a silent, eroding crisis within our own living tissues, the collapse of the human microbiome. This is the vast, invisible ecosystem of trillions of beneficial bacteria, fungi, and microbes that live deep inside our digestive tracts and upon our skin, working as an unsung army that regulates our digestion, manufactures our vitamins, and trains our immune systems to fight off disease. To understand the gentle, fragile nature of this internal ecosystem, close your eyes and imagine a heavy, earthenware jar sitting on the counter of a warm country kitchen, containing a decades-old sourdough starter passed down from your grandmother. That starter is alive, a rich, bubbling culture that requires the natural, diverse air of the old house, the trace yeasts of the wooden spoons, and the honest flour of the fields to maintain its unique strength and flavor. If you were to seal that starter inside a sterile, cold glass box filled with chemically pure, filtered air, the natural yeasts would slowly starve. The diverse culture would wither away, leaving the jar empty and dead. On Mars, the human pioneers must live inside sealed, hyper-filtered bunkers where the air is continuously scrubbed by advanced mechanical filters to remove the toxic desert dust. This creates a hyper-sterile environment, a world completely devoid of natural dirt, plants, and organic diversity. Over months and years, as the settlers breathe nothing but recycled air and eat processed, hydroponic food, their internal microbiome begins to collapse, losing its rich diversity like an overmanaged field losing its wildflowers. Their immune systems, left with no natural enemies to train against in the clean air, grow weak, confused, and fragile. If a single, ordinary bacterium from Earth accidentally mutates within the closed water loops of the colony, it could trigger a catastrophic epidemic against which the weakened pioneers have zero natural defenses. They would become prisoners of their own sterile cages, unable to touch the soil of any world without facing lethal infection. As we close the medical journals and accept the fragile limits of our own flesh, another cold reality settles into the quiet night. A city cannot live on survival alone. It requires a heartbeat of commerce, wealth, and value. Yet, across this vast cosmic void, the trusted laws of the free market begin to fracture, forcing us to balance a ledger where earthly gold holds no currency at all. For decades, the greatest critique of space exploration was its staggering, unsustainable cost, a perception that it was a luxury reserved only for giant governments spending taxpayer billions with no hope of a commercial return. But today, that paradigm has been completely shattered by private enterprise. The initial phase of our journey to Mars is already beautifully, robustly funded by an unprecedented engine of global commerce, the Starlink satellite internet constellation. For those of us who remember the early days of corporate enterprise, when a single great idea could lay the tracks for a global empire, this funding model carries a magnificent, familiar resonance. Imagine a visionary railroad tycoon in the late 19th century who dreams of laying an iron track across a vast, impassable mountain range to reach a distant, untouched coast. To fund that monumental, long-term dream, he does not simply wait for government handouts or empty loans. Instead, he builds a highly profitable network of short-line commuter trains between bustling, established cities along the way. Every single day, those local trains carry thousands of working men, freight cars of grain, and crates of mail, turning a massive, continuous profit. That daily river of cash flows directly into his treasury, providing the endless gold needed to blast through the mountain granite and lay the tracks toward the far horizon. The Starlink constellation is that highly profitable short-line railroad. By placing thousands of small, automated satellites into low Earth orbit, private enterprise has created a digital canopy that provides high-speed internet to the most remote corners of our planet, from cargo ships in the middle of the Atlantic to isolated farmhouses in the heart of the American West. This network generates billions of dollars in recurring revenue every single year, when combined with multi-billion-dollar aerospace contracts from the National Aeronautics and Space Administration to build the Artemis lunar lander. The first leg of the journey to Mars is completely self-sustaining. The cash is real, the business model is proven, and the avalanche of earthly capital is ready to build the first fleet of silver transport ships. But as our ships leave the cozy economic harbor of Earth and cross the black ocean of space, our financial blueprints encounter a brutal, unyielding wall of physics where the rules of the free market completely fracture. This is the net resource deficit paradox, and it represents an open wound in the dream of colonization for which modern economics has zero answers. You see, the fundamental illusion of our modern financial system is that digital numbers on a computer screen or green paper bills in a leather wallet represent true wealth. On Earth, that illusion works perfectly because we are surrounded by a rich, living biosphere. But the moment our silver ships touch down on the dead, freezing deserts of Mars, that illusion evaporates into the thin air. Paper money, stock market options, and digital bank accounts hold absolute zero currency on a dead world. Mars does not care about the Federal Reserve, and it does not recognize Wall Street. On the red planet, true wealth is measured only in physical mass liters of breathable oxygen, gallons of clean water, tons of structural steel, and bags of organic soil, and this creates a terrifying one-way economic drain. Every single item required to keep a human being alive, from the delicate rubber seals in a life support valve to the complex antibiotics in a medical bay, must be physically manufactured on Earth, using real, finite terrestrial resources, and then thrown into a one-way space sink from which it will never return. For those of us who love the rich, rugged history of our ancestors, this economic trap can be perfectly understood if you close your eyes and imagine the wild, chaotic days of the historic California gold rush. Picture a desperate, sun-baked prospector standing in the middle of a barren, rock-strewn canyon in the Sierra Nevada mountains during the scorching heat of a mid-August afternoon. In his rough, calloused hands, he holds a massive, heavy brick of solid, pure gold that he has spent months digging out of the earth. He is technically a millionaire, possessing immense wealth by the standards of San Francisco or New York, but he is stranded miles away from civilization. His canteen is bone dry, and his horse has collapsed from exhaustion. In that silent, desperate canyon, his massive brick of gold is completely worthless. It cannot cool his parched throat, it cannot shade him from the blistering sun, and it cannot give him a single breath of life. If a wandering trader rode by with a single cup of cold, sweet spring water and a fat, healthy pack mule, the prospector would gladly, instantly, trade his entire fortune of gold for that single drink and a chance to survive. Physical survival always overrules the artificial value of currency. On Mars, the entire colony is that stranded prospector, but on a grand, planetary scale. To maintain a population of thousands of pioneers, Earth must continuously export millions of tons of real, physical hardware, machinery, and raw materials. But because the cost of escaping Earth's heavy gravity is so high, Mars can never export anything of physical substance back to our home world to balance the ledger. Even if the pioneers discovered a mountain made of solid diamonds or pure gold on Mars, it would cost more in rocket fuel to ship that ore back to Earth than the gold itself would be worth in our markets. The entire Martian economy becomes an intangible illusion, relying on the export of intellectual property, media broadcast rights, or digital patents to pretend it is paying its debts. But you cannot build a greenhouse out of a digital patent, and you cannot breathe an intellectual property right. The physical reality remains a massive, permanent deficit. A system where Earth must continually bleed its own physical resources to keep a tiny bubble of humanity alive in a dead desert. As of tonight, modern economic science has zero models for a permanent, one-way colonial economy that can survive without causing a slow, draining bankruptcy of the mother world. When we think about managing a city on a dead world, where every single scrap of food, every drop of water, and every breath of air must be accounted for, standard capitalism falls short. You cannot have a wasteful throwaway consumer culture when resources are infinitely precious. To solve this, our finest economic minds have designed a flawless theoretical model known as the circular economy. This is a system managed entirely by advanced artificial intelligence networks that track the life cycle of every single atom within the colony. For those of us who appreciate the meticulous, honest craftsmanship of the past, this closed-loop economy can be perfectly understood if you close your eyes and imagine a master watchmaker's workshop from the late 19th century. Picture a quiet, wood-paneled room illuminated by the warm, golden glow of an oil lamp. On the velvet-lined table sits an intricate, antique clock mechanism. The old master does not throw away a single copper filing, a single stray metal shaving, or a drop of lubricating oil. Every tiny piece of metal swept from the floor is carefully gathered, melted down in a miniature crucible, and forged into a new gear or a fresh spring. Nothing is wasted. Everything has a permanent, calculated value, and the workshop exists in a state of perfect, self-contained harmony. On Mars, the artificial intelligence network acts exactly like that meticulous old master watchmaker. Instead of tracking arbitrary paper currencies like dollars or euros, the colony's economy operates on the absolute unyielding laws of thermodynamics. True value is measured strictly in precise, physical units, watt-hours of electrical energy, liters of pure oxygen, and grams of organic nitrogen. If a pioneer creates a piece of plastic waste, the system instantly calculates its chemical worth, credits the citizen's digital ledger for the material, and routes the waste back to an automated recycling plant to be melted down into a new water pipe or a piece of medical tubing. Every single drop of wastewater is purified, catalogued, and returned to the hydroponic greenhouses. It is a beautiful, flawless ballet of mathematics and efficiency, a solved economic blueprint where waste is entirely eliminated from the equation of human survival. But when we step away from the beautiful harmony of the computer models and look at the actual ownership of this technology, our blueprint encounters a terrifying, historic shadow that modern political science has zero solutions to break. This is the company town nightmare, scaled up to an absolute, totalitarian planetary dimension. You see, on Earth, if a man dislikes his job, distrusts his local utility provider, or disagrees with the political opinions of his landlord, he can simply pack his bags, put his key on the counter, and drive across the state line to start a fresh life in a new town. He can breathe the free air of the open road, drink from a public river, and sleep beneath the stars without asking anyone for permission. But on the red planet, every single cubic centimeter of breathable air, every drop of sweet water, and every protective wall shielding you from lethal cosmic radiation is owned, manufactured, and controlled by a single, private, corporate entity, the space transportation company that built the infrastructure. This creates a monopoly on human life itself. A terrifying return to the dark. Oppressive days of the Industrial Revolution. For those of us who carry a deep, respectful memory of our nation's history, this corporate trap carries a chilling, familiar resonance. Think back to the historic coal mining valleys of West Virginia and Kentucky in the late 19th and early 20th centuries. Imagine a weary miner walking home in the blue twilight of a freezing winter evening, his face stained with black soot. He lives in a wooden shack owned by the coal company. He buys his dry flour and salted pork from the company's store, and he is paid not in honest silver or gold, but in company script privately printed paper vouchers that are completely worthless anywhere else on Earth. If that miner dares to speak out against the dangerous working conditions, if he tries to organize his fellow workers, or if he falls ill and cannot work, the company police instantly evict his family into the snow, cut off his credit at the store, and erase his entire existence with the stroke of a pen. As the old, haunting folk song reminds us, he has traded his youth away, and he owes his soul to the company's store. On Mars, before the year 2050, this corporate monopoly becomes 1,000 times deadlier because the company does not just own your house and your food, they own the very air in your lungs. It is the ultimate expression of technological serfdom. If a citizen becomes a political dissident, if a worker refuses to perform a dangerous maintenance task on a freezing nuclear reactor, or if an individual speaks out against the corporate leadership. The governing artificial intelligence does not need a prison or a courtroom to enforce discipline. The corporate authority can simply choose to remotely dial down the oxygen flow to that individual's living quarters by a mere 10%, causing a slow, exhausting headache, or lock their electronic hab doors with a single line of digital code. There is no independent wilderness to escape to, no public well to drink from, and no constitutional court to appeal to. Survival requires absolute, unquestioning obedience to the corporate machine. As of tonight, human political science has zero solutions for how to maintain a free, democratic society when a private corporation holds an absolute technological veto over the very act of breathing. Yet, as the ledger books close and the cold machinery of commerce settles into the quiet night, we realize the deepest fracture is not found in bank accounts or supply lines. It is found within the human heart. Beyond the reach of corporate law lies the silent weight of distance, where our connection to the mother world begins to fray, and an entirely new, isolated human culture rises from the red dust. When we think of sending data across the solar system, we must abandon our fragile, earthly ideas of a continuous, unbroken internet connection. In the deep void, planets move, solar storms disrupt, and the massive bulk of the sun itself can completely block the line of sight between worlds. To survive this hostile landscape, our finest computer scientists designed a revolutionary network architecture called delay-tolerant networking, or simply DTN. It is an incredibly robust, self-healing system built to operate on a simple, brilliant principle: store and forward. For those of us who find a quiet joy in the rugged, romantic history of the 1900s, this advanced cosmic network carries a beautiful, deeply familiar resonance. Imagine the legendary Pony Express or the classic overland mail coaches crossing the vast, wild expanses of the American West in the 1800s, when a rider galloped into a remote canyon outpost in the middle of a torrential lightning storm. He did not panic because the trails ahead were washed out or dangerous to cross. He simply rode into the sturdy wooden barn, unpacked his heavy leather saddlebags, and safely stored the handwritten letters inside a dry iron lockbox. The mail sat there, perfectly protected, waiting patiently for days until the storm passed. The rivers receded, and the next rider could safely carry the bundle to the far coast. The cosmic DTN network acts exactly like that dependable old mail station. Instead of dropping data packets when a connection is temporarily lost or blocked by a planet's orbit, giant automated satellites hovering around Mars and Earth act as digital lockboxes. They capture the massive streams of data, entire encyclopedias, updated medical textbooks, news broadcasts, and Hollywood movies, and cache them securely in heavy-duty solid-state drives. When the alignment opens up, the data is pushed forward automatically, matching the changing geometry of the solar system with absolute mechanical precision. Because of this solved technology, a pioneer on Mars can wake up in the morning, pour a fresh cup of coffee, and browse a perfectly synchronized replica of Earth's Wikipedia, or stream a newly released jazz album, entirely unaware of the chaotic storms raging in the vacuum between worlds. But while the cold data can be stored and forwarded with flawless reliability, our blueprint for an integrated interplanetary society encounters a brutal, unbending law of nature that no amount of human genius can ever break. This is the absolute speed limit of the universe, the speed of light, traveling at a fixed rate of roughly 186,000 miles per second, because of the vast, ever-changing distances between our two planets. A radio signal takes between 3 minutes at its absolute closest approach to more than 22 minutes at its farthest distance to cross the void one way. This creates a permanent, crushing communication lag that averages roughly 20 minutes for a single word to travel from Earth to Mars, and another 20 minutes for the reply to return home. This means the immediate death of all real-time human interaction. The modern world we live in today is completely dependent on instant gratification, instant text messages, live video calls across continents, and split-second electronic financial markets. The moment a human being sets foot on Mars, that entire digital umbilical cord is cleanly, permanently severed. To understand the profound emotional weight of this cosmic silence, close your eyes and imagine the deeply poignant reality of an ordinary family milestone. Picture an aging grandfather sitting in his favorite leather armchair by a roaring fireplace in a quiet town in New England. He holds his modern phone, waiting to speak with his young grandson, who has just become part of the first generation born in the red dust of Mars. The grandfather presses the button and speaks a warm, loving birthday greeting into the microphone, his voice full of emotion. But when he finishes speaking, there is no immediate smile on the screen, no instant laughter from the child, and no shared moment of joy. His words must drift silently through the frozen void for 20 long minutes before they ever reach the child's ears. The boy listens, records his reply, and sends it back across the darkness. By the time the grandfather finally hears his grandson's little voice say, "Thank you," nearly 3/4 of an hour have slipped away into the night. The spontaneous warmth of conversation is replaced by a slow, agonizingly patient exchange of digital letters. There can be no live business meetings, no instantaneous emergency calls to specialists on Earth, and no shared cultural celebrations across the void. Every human interaction is stretched out, forced into a rhythm of slow anticipation that our modern, fast-paced minds are completely untrained to handle. This permanent delay will inevitably cause a terrifying cultural and psychological fracture, the birth of the isolated red information bubble, because real-time television and direct social media interaction with Earth are impossible. The Martian colony will rapidly withdraw into its own inward-facing digital world. They will develop their own local news, their own unique slang, and their own cultural inside jokes that the mother world can never truly understand in the moment. Over the decades, as the generations pass, the pioneers will look up at the tiny blue dot of Earth, blinking in their night sky, not as a familiar home, but as a distant, foreign shore that speaks a slow, historical language from a world they no longer truly belong to. They will become a separate branch of humanity, divorced from the daily heartbeat of the home planet. When the first silver transport ships depart Earth, they will not be entering a lawless wilderness devoid of order. Rocket scientists and international jurists have already solved the riddle of initial governance by looking back at the oldest, most trusted body of law in human history, the law of the sea, or Admiralty law. Under the foundational frameworks of the Outer Space Treaty, international law dictates that any vessel launching into the void remains under the absolute jurisdiction and control of the nation where the ship is registered. For those of us who carry a deep respect for the timeless traditions of maritime history, this legal solution carries a magnificent, comforting resonance. Imagine a proud, three-masted American clipper ship in the middle of the 19th century, sailing thousands of miles away from home into the wild, uncharted waters of the South Pacific. The open ocean belongs to no king, no president, and no single nation. Yet, the moment a sailor steps onto the wooden deck of that vessel, he is safely enveloped by the laws of his home country. The ship is a floating piece of sovereign territory. The captain carries the legal authority of the flag flying from the mast, maintaining order, settling contracts, and ensuring justice according to centuries of established naval tradition. The initial journey to Mars will operate precisely under this time-honored maritime blueprint. While crossing the black ocean of space, and even during the initial construction of the first outposts, the silver ships are legally recognized as flag state vessels. If a contract dispute arises between two technicians, or if a civil infraction occurs within the habitat modules, the law of the registering nation applies instantly and seamlessly. We do not need to invent a new system of space courts from scratch. The precedents are clear, the jurisdictional lines are locked, and the heavy anchor of earthly law keeps our early pioneers securely tied to the grand traditions of human justice. But the moment the colony attempts to transition from a temporary military outpost into a permanent, independent civilian city, our legal blueprints hit a brutal, unyielding wall of physics where the ideals of human liberty completely fracture. This is the terrifying reality of survival dictatorship, an open wound in the blueprint of space colonization for which human political science has absolute zero solutions. You see, the beautiful democratic institutions we cherish on Earth, the lengthy legislative debates, the checks and balances, the judicial appeals, and the sacred right to peaceful protest are a magnificent luxury, born of an abundant biosphere. On Earth, if a government gridlocks and fails to pass a budget for months, the air remains breathable, the rivers continue to flow, and the grass still grows. But on the dead plains of Mars, human life exists inside a fragile, synthetic bubble where every single second is a high-stakes battle against instant death. In an environment where a single open valve can vent an entire sector's oxygen into the void, or where a single delayed decision to ration electrical power during a global dust storm can cause the main life support heaters to freeze, democracy becomes a lethal liability. To understand this terrifying necessity of absolute control, close your eyes and imagine a heavy whaling vessel trapped deep within the crushing pack ice of the Arctic Ocean during a brutal frozen winter in the late 1800s. The hull is groaning under the immense pressure of the ice sheets. The coal for the stoves is running dangerously low, and scurvy is beginning to creep through the crew quarters. In that desperate, freezing purgatory, the ship cannot be run by a committee. The crew cannot hold a town hall meeting or cast democratic ballots to decide how many lumps of coal to burn each night, or who should venture out into the howling blizzard to clear the ice from the rudder. If they spend weeks debating the path to safety, the ice will crush the timbers, and they will all perish in the dark. Survival demands an absolute, unquestioned commander whose word is law, instantaneous and final, without explanation or appeal. On Mars, before the year 2050, the entire city must permanently exist under that extreme level of martial discipline. The governing authority must possess the absolute power to command labor, to strictly ration water and nutrients, and to instantly isolate or silence any individual whose actions or psychological instability threaten the structural integrity of the habitat. If an engineer refuses to work a double shift to repair a failing chemical scrubber, his defiance is not a labor dispute. It is an act of existential treason that could suffocate thousands of innocent children sleeping in the domes. This creates the ultimate political nightmare. How do you prevent a necessary life-saving survival dictatorship from hardening into a permanent, inescapable totalitarian regime that lasts for generations? Human history teaches us that once absolute power is concentrated into the hands of a ruling elite or a single commander, it is almost never voluntarily surrendered. On Mars, this tyranny is amplified 1,000 times over because the ruling authority also holds a complete technological monopoly over the switches that control the air, the water, and the heat. There can be no underground resistance movement, no strikes, and no revolutions, because the dictator can simply turn off the oxygen to any sector that dares to rebel. As of tonight, human political science has zero solutions for how to transition a society away from a mandatory survival dictatorship back toward human freedom when the environment itself remains permanently hostile to life. When a pioneer is placed inside a sealed metallic habitat millions of miles away from home, surrounded by nothing but sterile white walls, the hum of recycling fans, and the dead red desert outside, the mind naturally begins to starve for the sensory riches of Earth to combat this deep, aching homesickness. Rocket psychologists have successfully deployed advanced virtual reality therapy. This is not a mere video game. It is a sophisticated, medical-grade neurological intervention that can trick the human brain into feeling entirely at home. For those of us who find comfort in the quiet, rustic memories of our youth, this digital solace carries a magnificent, deeply familiar resonance. Imagine sitting in a comfortable leather chair on the covered porch of an old timber cabin in the mountains of Vermont on a crisp morning in late October. You can see the brilliant amber and crimson leaves falling slowly from the sugar maples, dancing in the gentle wind. You can hear the soft, rhythmic babble of a clear mountain stream rushing over smooth gray stones just beyond the grass. You can smell the sharp, clean scent of damp pine needles, wood smoke, and wet earth rising from the forest floor. You take a slow sip of warm coffee, feeling completely secure, anchored, and at peace. The advanced virtual reality systems designed for Mars pioneers can recreate that exact Vermont morning with absolute, stunning fidelity by utilizing high-definition retinal displays, synchronized acoustic arrays, and specialized olfactory dispensers that release real terrestrial chemical compounds. The system provides a perfect sensory escape. During the long, lonely months of the interplanetary voyage, a technician can step inside this digital sanctuary for an hour each day, allowing his nervous system to reset, lowering his blood pressure, and bathing his mind in the comforting memories of the mother world. It is a triumphant, proven solution for short-term psychological survival, a digital bridge that keeps the heart tied to the valleys of home. But when we look past these temporary digital band-aids and look at the reality of living your entire life on a dead world, our psychological blueprints hit a brutal, unyielding wall of physics where the human mind completely fractures. This is the terrifying emergence of cosmic agoraphobia, combined with the silent sociological tragedy known as the generational breakpoint. These are open wounds in the blueprint of space colonization for which modern psychiatry has absolute zero solutions. You see, on Earth, our minds evolved over millions of years to perceive the blue sky as a protective, comforting ceiling. The open air represents freedom, life, and boundaryless possibility. But on Mars, the sky is a lethal trap. If you step outside the dome without a thick, pressurized suit, your blood will boil and your lungs will collapse within seconds. Over years of living under this constant existential threat, the human subconscious undergoes a dark, pathological transformation. The open expanse of the Martian landscape becomes a source of intense, paralyzing terror, a phenomenon known as cosmic agoraphobia. Pioneers become deeply terrified of the windows, terrified of the airlocks, and completely unable to look out at the vast, featureless red horizons. Without experiencing a crushing panic attack, they retreat deeper into the artificial underground tunnels, burying themselves in the dark like blind cave insects, unable to face the infinite nothingness of the cosmic void. And beneath this individual terror lies the deepest, most heartbreaking sociological crisis of all, the generational breakpoint. Imagine the year 2050, when the first generation of children born on Mars reaches adulthood. These children have never felt the real wind on their faces. They have never seen a natural white cloud drift across a blue sky, and they have never dipped their toes into the cool, crashing waves of a real ocean. To them, the sterile plastic domes, the metallic hum of the life support valves, and the recycled taste of water are the only reality they have ever known. This creates an unbridgeable psychological gulf between the Earth-born parents and their Mars-born children. For the parents, Earth is a beautiful, lost paradise for which they weep in the dark, a world of green forests, rushing rivers, and ancient history. But for the children, Earth is nothing but an alien myth, a distant, terrifying planet with crushing gravity that would snap their fragile bones. A world filled with chaotic weather, wild animals, and uncontrolled biospheres that feel like a nightmare. When the parents try to share their love for the old country, the children look at them with complete indifference, boredom, or confusion. They do not share the heritage. They do not speak the same emotional language. And they hold zero loyalty to the traditions of the mother world. The human lineage experiences a clean, permanent ideological break. The Mars-born generation becomes a new, cold, and detached species of humanity, completely divorced from the history, the values, and the soul of Earth. Take a final, long, slow, and deepest breath, my friend, and let the absolute stillness of the night completely envelop your soul. We have traveled an immense distance together this evening, journeying across the cold, silent ledges of planetary physics, orbital geometry, and the fragile architecture of the human spirit. We have stood on the rusted plains of Mars, looking into the eyes of towering engineering giants from the chaotic fires of supersonic retropropulsion to the quiet, creeping tyranny of the survival dictatorship. The dream of building a gleaming new civilization of 1 million souls before the target year of 2050 remains a magnificent, unconquered mountain, its steep peaks guarded by the unyielding laws of the cosmos. But as the dark hours deepen, the grand clock of the universe reminds us of a simpler truth. The 11 launch windows will turn on their silent wheels of gravity whether we worry or not. The frozen lakes of Arcadia Planitia will sleep undisturbed through the ancient Martian night, and the cosmic rays will continue their endless, ghostly hiss across the empty void. The universe is patient, and its secrets are safely kept. There is no need to solve the great ledger of space tonight, no need to bridge the two planets before morning, and no more burdens for your shoulders to bear. The silver transport ships of our imagination have shut down their systems. Their hulls are cool, their cabins are dark, and they are drifting peacefully in the protective shadow of our home world. Let your thoughts dissolve entirely now into the weightless tranquility of this room. Feel the deep, comforting embrace of Mother Earth's gravity holding you secure, and thank the heavens for the thick, rich air that fills your lungs without cost or command. The busy world has faded away into nothingness, leaving only the soft, rhythmic ticking of the clock and the velvet dark of the evening. Your long journey is finished. The watch is over and the harbor is safe. Breathe out, release the final gravity of the earth. Close your eyes and allow yourself to sink gracefully into a deep, peaceful, and beautifully unbroken sleep.